So hi everyone. Today I'm going to introduce you to Assembly Assistant, the new app in Altium 365. Today in the webinar, we are going to show you how to simplify, speed up your manual assembly process. And some users, they have reported that the assembly times can be faster up to 8 times. So we are here with the XVP Photonics as well. And I'm going to go to the next slide. So first of all, I'm going to introduce the speakers. My name is Renata Lang. I'm the Product Marketing Manager at Altium. With me, it's Boris Raskin, the Product Director at Altium. And we both work with Assembly Assistant in Altium 365. And with us, we have two panelists, Francois Bertrand, the General Manager of XVP Photonics, and George Hiwegi, the Director of Operation at XVP Photonics. And they will share their experience with Assembly Assistant. So, before we start, I would like to ask you some questions, and I'm going to add a poll here. So, first, before we start, I would like to know a little bit about you. Can you see the poll? And I would like that you answer those questions. The first question would be, does your company do assembling house, prototype, manual assembly? And the second, how many boards does your company manually building in a month? It can be average. And we know that some months is more, some less, but in average. The third question would be on average as well. How many hours does it take to manually build a single board at your company? So I know that some of the simple ones, it depends of the time, but I would like to know on average. And who manually assembles boards at your company? I'm going to give you 1 more minute for everybody to answer. Would be very nice if you answer us, then we can help you to target better. So let's go to the next slide. I'm going to introduce you the agenda. First, we are going to talk about the Altium 365 platform, a brief overview. Then we are going to talk about Assembly Assistant. Next, XVP Photonics, they are going to talk about their journey as a company, and then they're going to share the benefits that they had with Assembly Assistant. And in the end, we are going to have a Q&A session. So first of all, I would like to talk to you about Altium. Altium is not only for design circuit boards. We have over 30 years of working together with the customers like you, and we learned that the biggest challenge happens when different teams come together. So imagine that's a big puzzle when you have a product manager, electrical engineer, procurement, software development, mechanical engineering, and manufacturing. So imagine that Altium 365 is the glue that you can have all these roles and personas collaborating together. So in the past, we have those silos, but now we have only one team working together at the same time. And that's Altium 365 does the collaboration part. So here we can see that for example, you're working a big project, right? Some people design the project, some building, the other manager. We have people that work in the mechanical part. We have people that work in also procurement, supply chain. So imagine that we are working with everybody working together at the same time. And that's what Altium 365 does for you. So imagine that, for example, Altium 365 does not replace tools like PLM and MCAD, but instead it links up. So Altium 365 works as collaboration tool more than a PCB design. And that's when we are going to introduce you Assembly Assistant at one part of this puzzle. So now we are going to talk about Assembly Assistant itself, and I'm going to pass the word to Boris. Thank you, Boris.
Thank you, Renata. Yeah, so today we're going to talk about the Assembly Assistant, which is one of our newest apps that can be used to manually assemble prototype PCBs. So if you've ever done that, you can imagine what's involved in the current process is usually a printed bill of material, as well as images of the board that can be used to place components. And that often results in a lot of time wasted for creating the documentation required for assembly, as well as errors in placement of components. So what we're trying to do with the Assembly Assistant is eliminate that paperwork and distractions and really make sure that the component placement is accurate, as well as really improve the overall user experience and make it much easier to navigate and make sure that you're always working with the latest up-to-date files. And in turn, that is meant to reduce the total time and cost for assembly. And based on our research, we found that for some users, it was as much as eight time reduction in assembly of the boards, of prototype boards. And that also helps increase the company's revenue as well as de-risk projects. So next slide. So yeah, so we do have, let me share my screen first. We do have a landing page on our website that you can go to after the webinar, and we're going to share the link to that with you. But once you're on the page, you can actually try out the Assembly Assistant by filling out your email and then clicking this link to open up the trial of the application. So if you're within Altium 365 and you have a workspace, you can also access it from within the project. On the left-hand side, you'll find the Assembly Assistant link. And what you can see right away is that this is a combination of a viewer of the board as well as the bill of materials here on the left. And what we can do initially when opening the app is really interrogate and look at all the different components on the board. And when you click on the components, it will zoom into either the group of components that you have or individual components if you click on those here. You can also get more information on the different parts by clicking on them, and that will open up the properties panel. That also gives you the part choice and all the different parameters. But first, before starting the assembly here, we're going to also look at some of the options that are available. And we can group them by components or separate them and break them up into individual components so that it's easier to go one by one. Right now, the board is split based on the top side and the bottom side. So you can to kind of join all of the components kind of into all the similar components into the same line items. You can turn that off and that will join everything together. And then also for, you could see either the board assembled or without the components, and also even switch to the 2D preview of the PCB. There's also a way, if you're looking for specific components, to actually find, if you're looking for all the resistors, you can filter based on those in the search filter here. And finally, there is a way to show additional columns. So if you have a part number, manufacturer part number that you're trying to show in the table, that will help with the assembly, you can do that here as well. So we'll leave that up now. And now that we're ready to start the assembly, we can do that, and it will take us through the entire board line by line. And you can see on the bottom here that we do have keyboard shortcuts. So if you're assembling the board and it's very hard to use a mouse because your hands are occupied, you can just reach over and hit the space bar to mark the component done. So instead of pressing and clicking this done button, you can hit the space bar and it will give you the same result. If you have large components that you'd like to skip and leave for later on, you can do that by clicking escape. And so that will skip those components. And you can also flip the board if you'd like, and just in general navigate using the up and down arrows, or hit I to open up the information, the properties panel. So we're gonna just go ahead and pretend that I've placed all of my components on the board on the top side and bottom side by hitting the space bar to mark all those done. You can see that here it's coming back to the same components that I've skipped. Other thing worth mentioning is we do mark where pin 1 is. So for all the polarized components, like diodes, or especially when there's pin 1 isn't marked very clearly in the silk screen, it's very easy to see which one is the pin 1. And once that's complete, you can see that the progress bar on top has been filled. We've populated all 101 components. You can see the total time it took to assemble. And if you're ready to reset the progress and actually start the assembly over for a different board, you can do that using this reset button at the bottom. So, today, basically, I've tried to show you how you can use the Assembly Assistant app to eliminate all the paperwork and headaches that are usually associated with manual assembly of prototype PCBs. And this assembly using this app will speed up the total assembly time. It will help you improve the accuracy of component placement, reduce the errors, and in turn save you and your company time and money. So at this point, I think I'll hand it back to you, Renata.
Thank you. I'm going to share. So now let's talk about XVP Photonics. So Francois Bertrand, thank you.
Thank you, Renata. Thank you, Boris, for this opportunity to present the XVP. I'll do a very quick job. There's 15 slides, and I believe the content will be archived. So I'll go quickly over this and give you an opportunity to talk about the electronics aspects of this of our company. So the company was founded, next slide, please, Renata. The company was founded in 2008. It specializes in engineering services for photonics, optoelectronics, and process automation. And as the name of the company implies, the team members here consist, for the most part, of ex-engineering management level people who, over the course of their long careers, felt that the latter component, namely the management part, was kind of interfering with their love of designing things, working in a lab, and providing innovative solutions. So XVP is a small company, but with a team of very experienced people. And as we provide those services, you'll find that there are a lot of corollary skills that we've developed, which are pertinent for the presentation that we have today. Next slide. Our mission essentially is to accompany customers, provide engineering services at various aspects in their product development cycles. Sometimes it's an 80-hour study. Sometimes it's a 2-3 year commitment to help a client during things like ECO management or board redesign. We provide services on either end of those scale. Next slide. We provide these services and we pitch it as an extension of an engineering department at large companies. So we have to make sure that our offices reflect that ability to provide those services. So here you see our staging areas where we put up the machines and develop processes for clients. We have a chemical lab. We have an environmental lab. We have a small machine shop. And we have the ability to, with the engineering people in electronics, to provide also electronics services, which we'll delve into more details. Next slide. Of course, the company has regular offices, a pretty large photonics lab. And next slide, please. We use this to provide a ton of services, which we don't have time to do justice to every one of those things. But the message that I want to convey here is that this is engineers selling to engineers. So we invoice by the hours. All the IP developed in our project is owned by the customer. That includes electronic designs and boards. And we've provided our clients help to file for patents in a number of instances. So since they pay, they own everything. Very straightforward business model. Next slide. I don't want to go into any details about what we do with our clients for our clients because it's subject to confidentiality clauses. So we've got this kind of block model. I'll only talk about the first two line items, photonics and electronics and firmware. Next slide outlines some of our expertise specifically in the field of photonics. And if you go to the next slide, you'll see some actual projects that we can broadly talk about. For example, with the rise of autonomous vehicle and new ADAS environments for cars. XVP is pretty involved in LiDAR engines and LiDAR front ends. And it's something that's maybe closer to everyone here is that in the medical imaging space, for example, we've developed a number of medical grade devices from fiber laser in the IR spectrum to intraoral probes for the dentistry and implant markets. What's unique about XVP is because so many people with so much experience, we're not doing only clever design, but we're really specialized in developing automated assembly, test, and calibration equipment. And that distinguishes our offering from other companies providing services in that space. Next slide. This is an overview of what we do in the electronics area, and we'll go into details today on that. So I'll move on to the next slide. So broadly speaking, we basically do board layout design, schematic design. We buy parts, we build stuff internally. We support FPGA programming, FPGA functionality. And because of our clients' requirements, we're also familiar with EMC or safety standards that are required for electronics design. Next slide. George provided a list of more specific areas that we've worked on, more specific projects. And what I want to let you know is even though we're specialized in photonics and optoelectronics, we're not faced by any electronics challenge, basically. We're able to tackle quite a few things with the skill set that we have internally. Next slide. This is some of the equipment that we use. And this is one of an unsung benefit of having a bunch of old peoples working together. Is we were there in the 1986 crisis, 2000, 2008 crisis. And as companies go up and down, we managed to buy all of this equipment basically from those various companies that are part of our ecosystem. And today we have a pretty nice lab that we use every day to support our customers, basically. So we've been able to garner a lot of equipment over time, and we have a couple of very smart technicians who make sure that they operate up to snuff there to the latest and best standards in the industry. Next slide. We can obviously test what we do. That's very important. So we have nice equipment to actually validate the equipment, the designs that we make for clients. Next slide. And we've developed also a pretty nice expertise in software and automation, and depending on our customers' requirements, we're able to support not only the design of very complex photonics design, but also the electronics, the back-end, the man-machine interface. So that's it, basically. Thank you for your time. And with XVP, what we try to do is make sure your prototype is ready for real-life testing in a hurry. That's what we sell. That's what we try to provide with our installation and our skill set. Thank you very much.
Thank you so much, Francois, for your introduction. And now I want to talk with George about the benefits of assembly system on applications at XVP Photonics.
Renata, thank you, board. So one of my responsibilities at XVP is to support the electronics design group's rapid prototype assembly service. And as Francois mentioned, quick turns are important, quick turnaround for on product, on designs. And I guess most of you have experienced working with contract manufacturers that are great, but usually it's a long process. Minimum order quantities and not necessarily suited to product development. So at XVP, what we can do is design the product, you order the boards, and within a couple hours, the same day, the design engineer has a working board, the first working board in his hand, which you can debug, and then you can decide, let's build a few more, or let's make some changes, and so forth. Here, this is just, it's another photo of what Francois showed, just to put into perspective the assembly station. We have that. This is today's assembly station. So there's a pick and place machine. On the leftmost monitor is the assembly assistant, which the operator will navigate with the mouse. Center screen is the pick place camera view. Mostly those are used together, and then on the right-hand side that's just another it's another camera for the BGA placer. Next slide. So this is an example of what we used to do for what I used to do actually in a previous life for documentation. This was before assembly assistant. This is it's a third-party software called Unidoc. They don't exist anymore. And basically, this was a documentation specialist that would work full-time to put together instructions. This is in PDF. You see there's 40 pages in this one, 578 components, and we try and divide up the components on one page to save the number of pages. So this can be viewed electronically, but you still have to follow with a ruler or highlighting or whatever. It's not the most functional tool, but it's something if you have someone you can dedicate to it. Next slide. So for smaller boards, when we don't want to resort to any kind of documentation, we would occasionally just print off some silkscreen prints, multiple copies. Here I'm showing just one silkscreen where we've highlighted, let's say, 4 components or 3 components. And you'd follow along in the bill of materials with a ruler. Again, it's something quick to save on documentation time, because if you're building 1 or 2 prototypes, you don't want to spend 2-3 days to generate documentation for it. So it's a little clunky, but that's what we used to do. Okay, next slide. So recently, we've been working on some larger boards. This one has the bill of materials is 987 components. There's actually 930 on the top side. So here, because it's such a large board and manually assembling it is quite a few hours, we took a different approach. 2 operators. So one operator would follow in the bill of materials and then call out grid quadrants to the other operator who would be placing. For example, U15, he'd say is in G5. And then the second operator would place that part. And the first operator would continue going down, calling out part by part, and then calling out the grid coordinates and zooming into the area sometimes. So there needs to be very good coordination between the 2 operators, and obviously it's 2 operators, so it's It's not ideal. Next slide. All right, so this is what we do today. This screen capture here represents the two left side monitors that you saw in the station. So on the left monitor is Assembly Assistant, which Boris ran through previously. And on the right side is the camera view in our assembly station. Next slide. Right, so this is the same board. So here we have just the Assembly Assistant view, just to see it a bit better. There are, in this example that I chose is 49 capacitors to install. You can see they're all over the board. This is like it's a 5-inch by 8-inch board. And so what we would do is you select a quadrant, which is roughly the same size as the camera view. It's highlighted in red here. And then we would zoom into it. So next slide. So this is the zoom view, which we saw in the previous slide. And what's nice about this, what we really appreciate, and it's hard to appreciate, is that the Assembly Assistant view is exactly the same, or can be sized exactly the same as the camera view. This makes the operator's job a lot easier because everything's scaled the same. So it really cuts down on the search time, if I could use that term. And the other thing that's nice here is that, and I don't know if anyone picked up on this in Boris's demo, but even without reference designators, you can place the components easily. They're all highlighted. Now here, we're placing by group, but you could, in the left-hand side, you could individually click on every single component, or as Boris mentioned, you could list them in independently and just go one by one. Next slide. Right here, I did this screen capture. This is, the operator was about to place this IC, and at the time, I didn't know where pin 1 was. So before we learned what we learned from Boris, that there is actually a pin 1 indication there on the left-hand corner. We didn't notice that because we like to bury vias in our pads, and if you look at all the resistors, there's a lot of dots there. So we didn't catch on quickly, but it's still relevant because there's a very quick and easy way to get more information. Whereas previously you have to call the engineer or whatever. Here, if you go to the next slide, Renata, this is again just the Assembly Assistant view at the top. You just tab from, you select the design view, Altium 365 design view instead of the assembly view, Assembly Assistant, and you zoom into your components. And this is how, at the time, we found out, chose to identify pin 1. You zoom in, there's your pin 1. And as Boris explained, you have all the details on the side there, so you can click on the data sheet. We often use this for LEDs that don't necessarily, small LEDs that don't necessarily have a very clear pin 1 indication. So it's really nice to have all this all at your fingertips. And it's very intuitive. So last week, we trained an operator in about the same time that it took Boris to do the demo. It's very easy, and it's very powerful as well if you want to use it for engineering. So that's all I've prepared. I mean, I can go on for hours, but our time is limited. So
yes,
that's it for me.
George, thank you so much for sharing your experience with us of using the Assembly Assistant. I just have a few questions. Primarily we talked about the time savings associated with using the app, and we did find with various customers that the time savings it will take in some cases 8 times less time to assemble a board. In your experience, what have you found for assembling? How much time are you generally saving for an average board?
Okay, so it depends on the complexity of the board, the component count and component mix. But right off the bat, if you look at just the previous one, there, one of the documents that the complex documents are hours and hours and hours. So a functional assembly document can take anywhere from 2 to 10 hours to do, and so that's completely gone now. There's nothing. You just open up Assembly Assistant and there's your instructions. So that's a huge savings. That's huge. We have with our semi-automated or manual machine there, we're quite streamlined in terms of assembly. So we may not realize the savings that some other people have, but definitely Assembly Assistant also helps in placement time. So easily 25% faster to place a part. And the reason is, I mentioned before that everything's all in the operator's field of view. So there's no searching. And when you're placing 900 components, every second counts. So especially on more densely populated boards, you can zoom in, and here's an example. It's not a very good example. I took some screenshots of what I was working on at the time, but in more densely populated boards, your search time is a lot shorter. So there's a big savings there. And then what you might not realize is also savings in the quality, so to speak. So because when you place components, as you show, once the components are placed, you have the 3D view of that component on Assembly Assistant. So again, it lines up with the camera view. Yeah, you could kind of see it here. It's not a great photo on the right, but you see that there's some components already there. So that's another landmark for the operator. It makes it easier to locate the part, and it helps with the quality in terms of not making mistakes. So that obviously saves time in debug and bring up and rework.
So it sounds to me like the accuracy and the precision of the component placement has also been improved with the app.
Sure. If you think about even the complex document that I showed at the beginning, that you still, it's nice, it's visual, but you still have to follow with the ruler, and you have to mark off. You have to find a way to, either with a ruler or a highlighter, to mark off the components that you've placed. So even just keeping track of your progress, it all adds up. There's a second here, 2 seconds there, so it all adds up. And yeah.
Thank you. Are there any other workflows or tasks you can think of? I think when we spoke earlier, you mentioned inspection might be also a good use case for this.
Yeah, so we started using it for inspection. So inspection or rework. Let's say we build the first board, and the design engineer says, okay, we'd like to change these values, and gives you a list of values. So as I think you demonstrated, you can quickly just type in the search field your component, and it zooms right in. So it's accurate and it's quick. We use it also for inspection. For example, if we want to make sure that we've not populated all the do not populate locations, it's easy to scan.
Okay. Sounds good. Well, George, that's all the questions I had. Thank you, George, Francois, for your presentation. Renata, back to you.
Thanks so much, George. That was great to hear. So, well, now I would like to thank you. Thank you, George and Francois, for sharing the experience, the real-life experience. Thank you, Boris. Thank you for XVP Photonics team to put it together, everything to being part of a webinar. So the final pool and the Q&A will begin shortly. And I would like to inform you that everyone is going to receive a recording of this webinar and also take away in your email. So if you register, you are going to receive shortly a recording and a sheet with your email, within your email, okay? Well, do you remember that Boris showed you a website? So this is the website. So we have the full website here in altium.com. We did a short, but we also did a QR code. So you have your phone now. You can just show through your phone, access the website. And then there's a field there that you can add your email to try, like Boris said. So please, if you have the chance, you can do that. It's really easy. And if you have any questions, just let us know. Okay, so before we go to Q&A, I'm going to talk how it works Assembly Assistant now. So now we are in open beta. So we are in before release test. Before release, we are in open beta. So it's active for you to try with no cost. Just go to Altium 365 and test Assembly Assistant. So if you want to try with a real example, like Boris said, it's really easy. You just click there and it's going to show you. So we don't have a date for the public release yet, but if you add your email that on the page when it's the public release, you're going to see before everybody when it's going to be public. Okay. So I received some questions about how it's going to be. And when we release, for now, the beta is for free. But when we release, the price per year for Assembly Assistant, it's going to be $1,200 a year. So if you add your email and if you try beta, then we are going to do an early access price with a 50% off. As George mentioned, this is a very good saving, for example, for your board, for your time, for your operator. So this is going to be associated with a unique username. And when we are going to release, if you are on the email, you are going to receive an email with all the information. Thank you all for participating. Thank you for our panelists. And yeah, so we are going to receive an email soon.